my variable y, integrating to find y. Where if I derive y, make a derivative for y, I back to the original equation. This is very simple definition for it. Okay, let's verify it. Verify to see this is correct or not. I will take two examples here. This is, he told you as example, this is first order differential equation. Its solution is this. What I will do, I will substitute for y here, and I will differentiate and substitute it here. If the equation left hand side equal right hand side, then this means that this is solution. Have a look. Okay, I will say, okay, first of all, let me differentiate y. Y is 4x to the power 4, okay, 4x to the power 3 over 16. After I simplify, this is what I got. This is the derivative, this part. I will come here, I will substitute y by its value here. As you can see here, I simplify x by y here. Simplify, I got this. Just a minute, they are equal. It means left hand side equal right hand side. Then this means this is a solution. Let's take another example. He gave me here second order differential equation, and he told me that this is the solution. Okay, I will come, I will substitute for y dash after I differentiate them twice, and by y dash I differentiate once, and by y, which is already given here, and simplify. When I simplify, I found that the left hand side also 0. So 0 equals 0. This means that this is a solution. Now, what type of solution we will have? We will have explicit solution and implicit solution. Explicit solution is very simple. Y is function of x directly. Y to the left and everything else to the right. This is called explicit. Very precise, accurate, direct. Okay? While there is another solution which is implicit, where x and y are mixed together. Okay. Now example, have a look at this is, okay, this is yx squared plus y squared equal 5. We call it implicit solution because y and x are together. Okay, for this differential equation, he told me in this range. When I come and I differentiate this equation. This equation, x squared plus y squared equal 5, I reach here. Okay, simplify, I'm here, and then you find here, oh, it is the same solution, okay, for this equation. So this is correct. Now, how it look like the implicit? Implicit, when both together, it gave me this circle between x and y. And if I want to find y, I will take this y squared, it will be here minus x squared, and take square root here and square root here, it will be plus minus 2 square roots. So I will call them y1 and y2. As you can see here, this is how it look like the implicit for this one and for this one. Very specific. Sometimes when we integrate to solve the differential equation, we will have a constant c, which is called integration arbitrary constant. Now, this c could be any value. If you give it infinite number of values, you got infinite number of solutions. Okay, so we need to consider this. Usually, initial condition given to you to find. As example, this equation here, okay, first order differential equation, its solution here. Okay, but when we solve it, we will come up with a constant. As you can see here, sorry, here we have a constant. If c is 0, this one will disappear. We have only this. But if c can have any value, okay, then we have, as you can see here, infinite number of solutions. Now, to find the specific solution, the explicit solution, we need to have initial value problem. Initial value problem, you are given the differential equation, but at the same time, you are given initial conditions. You use them to find the constant if it is one or more, and then it will be explicit solution. Another property I would like to define here is the homogeneity. Homogeneity actually what's happening is the all terms of the involved the dependent variables should be on the left hand side, and to the right hand side we will have 0. Then this means that this is homogeneous. Okay, homogeneous. And if it is not like this, we call it non-homogeneous. I will give example. Now see this equation, dv over dt equal g. You can see here v is the variable, first order, first degree, and here he gave me initial condition, so I can list these. It is first order, it is linear, there is no non-linearity in this formula. Okay, non-homogeneous. Why? Because here g to the other side there is a function, it's supposed to be 0, and here he gave me initial value problem. Another example is d square m over dx square equal w. This is second order. This is linear because there is no sort of nonlinear source of nonlinearity. This is non-homogeneous because of w. And here he gave me boundary condition. It means m to be changed from 0 to L. For x it will be changed to be 0 or 0. Another example, this is second order, okay, as you can see here. Okay, theta is my variable, and since sine theta it is nonlinear, and then it is homogeneous because as you can see here 0, and it is initial value problem because he told me theta equal theta naught at time 0, and at time 0 d theta over d theta dt equals 0. Another example, this is second order as you can see here, but this is linear because square here on the constant, not on theta. Theta is my variable. It is homogeneous because of the 0, and he gave me initial value problem. Now how we solve differential equation? We can solve them using mainly two methods, numerical and analytical. Numerical to be discussed in level 3, okay, but now in this level we are discussing only analytical. And for analytical there are many methods, but we will focus on direct, integrable, separable, exact, linear, and Bernoulli. This week we will start with the phase 2, which is direct. Direct, very simple, from the name is direct. It means you integrate directly, you come up with the output. Example, he told me as example here, find the velocity of a car that is accelerated from rest at 3 meters per square second. Okay, he gave me the formula dv over dt equal 3. Okay, now directly I integrate, I will come up with v equal 3t plus constant. Constant, if I want to find it, is supposed to give me initial condition. Let's say he say at time 0 the velocity is 0, then velocity is 0 at time 0, then I got the constant which is 0. Then if I pack and substitute here, then this is the final answer. It is called direct. Okay, another example here, you can see y dash equals sine, integration of sine is minus cosine plus constant, and so on. I gave you here some exercises. I advise you to solve them at home, enjoy it. This is direct, okay, and some of them are separable as I will explain. Now here he asked me to find general solution. We need to be familiar with this terminology. General solution means we have constant c, okay, and there is no initial condition, we can't find it, we cannot find it, but if there is, we can find it. Now if I look to this function here, you can see that this is x square, x to the power 3, x square it will be x to the power 3 over 3, and x to the power 3 it will be x to the power 4 over 4. Very simple and direct. And this is another one, x to the power 3 it will be x to the power 4 over 4. X it will be x to the power 2 over 2. He told you as example when x is 7, y is 4. Let's substitute. You see here 4 and here 7, we got the constant. You see, he asked me here general solution. He didn't give me initial condition. I need to prepare my equation, but don't forget this is square root of x, as you learned before. It will be x to the power 1 over 2, and then you use the formula to the definition for integration, and then find the solution. Particular solution. Particular means he give you initial condition. He told you x0 at y1, and here you can say directly x to the power 4 over 4, x to the power 2 over 2, as you can see here. We want to find c, then let's use the initial condition, as you can see here 1 and 0 for x, then find c. And if we got c1, then back and substitute here, we have the particular solution, specific. Another example here, okay, you see here y square, but here t and exponential t square. I know how to find integration for exponential t or minus t, but t square I need to go for the substitution. You see here I substitute t square by u and convert this equation into function of u, as you can see here. This is equation, convert to function of u, and then you integrate, you will find it easily. Back from u to t, as you can see here, it will be t square. If he gave you initial condition as in this example, use it. Here t is 0, y is 1 over 2. Substitute to find c, and then back to find to substitute the final answer. Now direct is direct and easy. Now let's go for separable. In separable, the derivative dy over dx is equal to two functions x and y, function of x and function of y. Here we will separate between these variables. Let, as example, say y variables to the left hand side and x variable to the right hand side. As example, this one, as you can see here, this is x and this is y function. I will take it down here and this one take it here. We arrange, we are here. Now integrate here and here, okay? As you can see here, simplify. We integrate. This one will be x squared over 2 and this one will be x to the power minus 2 plus 1 over minus 2 plus 1, as you can see here. Now I have constant for this right hand side, left hand side, and for right hand side I will take this to minus, it will be in minus, so c2 minus c1, I will call it c, one constant, no need to put more than one constant. Simplify more, okay, arrange, let me say take a reciprocal and arrange and take this y here and this part here. We got y equal minus 1 over x squared plus c. If I am given initial condition, okay, then I can find it. Otherwise, it is general solution, and if I sketch it, it will be look like that. As example, dy over dx equal x over y. Separate them, cross multiply. We are here. Integrate y squared over 2, x squared over 2. Now this is with the plus c. Now this is, let me say, general solution, and we don't have value for c. Okay, it gives me infinite number, as you can see here in this graph, infinite number of output. Now initial condition will solve this problem, because when you are given initial condition, as example, previous example we just solved, we have c here. He told you that at x0 y is 2, so let's substitute here by 2, here by 0. We can find c is 4, and then I back to substitute here c by 4 to go with the final particular answer. Another example here, you see here, this is function of y and this part function of x. Let's separate them using simple equation, let me say, properties. I separated them, then I will integrate, as you can see here. Okay, now this one remind me that there is a similar formula in the integration by trigonometrics. You remember the table with 12 formula? One of them is similar to this one. Its solution is direct here. While this one, as you can see, x squared I can assume to be u and convert the whole formula here into u. As you can see here, u equal x squared, du equal 2x dx, as we learned before, and convert to u and then integrate. This will be direct integrable. Okay, as you can see here, direct. Simplify more. Okay, and back to x here. Take this c to the other side and it will be c2 minus c2, I call it c. Okay, now we can simplify more to get y alone to the left. As you can see here, I will take tan for both part of the equation. This one will cancel with this one. What is left is y equal this part, exponential x squared plus c. Okay, I will stop here. Have a nice day.